Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6C Part 2 assignment. First one we're going to take a look at here is 1B and 1F. Find the volume of these pyramids here. Okay, so pyramids and cones, what you want to do is find, it's going to be 1/3 the area of the base times the height. Okay, so basically just got to find the area of the base, multiply it by the height, and take 1/3 of that. Okay, so we get for this one here, volume equals area, let's see, let's do 1/3. Area of the base is going to be 2.8 times 1.7, right? And then our height here, they give us, which is nice, is 2.9. Okay, so the volume of this thing here will equal 1 divided by 3 times 2.8 times 1.7 times 2.9. That whole thing there, and that gives us 4.6. 4.6 centimeters in its volume, so it'd be centimeters cubed. Okay, on this one here, we'll do the same thing. Volume equals 1/3. The area of the base is going to be 8 times 8. And the height they don't give us, but they do give us this slant height piece here. So what we got to do to figure out what this height is we're going to have to figure out this piece right here. So if you think of this, like let's draw this. We're going to draw this triangle right here. That was a pretty bad one. I can actually draw a straight line on that one. So think of this here as the triangle. So we know that this, let's see, we don't actually know what that slant height is there either, right? So let's do this instead. Let's make our triangle go all the way out to here. So I'm going to redraw that. There we go. That's a little bit better. So this is what we want to find. So let's see. Let's do this. I'm going to redraw this triangle out here so we don't have to look through the rest of the pyramid to figure that out. So we want to find this. We know that this length right here is 12 because that's this here. And then to figure out what this is here, we're actually going to have to draw a different triangle. So this is a tricky one. So we draw just a picture of the square base here. So here's, like if we were looking straight down on top of the triangle, this is 8, this is 8. We got to know what that is right there. So really what we can do is find this whole length here, which we can do because this is a right triangle. We would just do 8a squared plus b squared equals c squared, right? That's an a, not a 9. So we would do 8 squared plus 8 squared equals c squared. That's this whole length right here. So 64 plus 64 is c squared, and then we add those two together and get 128. Square root both of those to get that this c part here is, so I'm going to do square root of 128, and we get 11.3. All right, so that's this whole length right here, but we only want half of that length for this right here. So we're going to take this 11.313, divide it by 2, and that gives us let's go with 5.66. Okay, so this is 5.66 for that length there. Okay, so now that we have that, now we can go back up here and do, again, a squared plus b squared equals c squared. And let's see, the important part is that the c is 12. And we can do 5.66 squared plus our height squared, right? So there's our 5.66. Let's just, take that answer and square it, and we get, oh, look at that. That gives us exactly 32. So this is 32 plus h squared equals 144. Subtract the 32 from both sides, and we get h squared equals 112, right? So square root both of those, and we get that the height then, again, I know this is a lot of work to get that all figured out. So we're doing the square root of 112. Oops, not 12, but 112. There we go. We get 10.6. So now we can multiply that by 10.6, 1/3 base times height. Okay. So when we do that, that will give us 1 divided by 3 times 8.8 times 10.6 gives us 31.1 we'll go with. 1.1 centimeters, and it's volume, so centimeters cubed. Sorry about that. I did 8.8, I believe, and we're supposed to do 8 times 8. Okay, so go back into that, and we want to edit this 8.8 to be 8 times 8. There we go, 226. 226 centimeters, 226 centimeters cubed. Okay, 8 times 8. I should make that more obvious. Okay, let's look at the next one here, number 2, part C here. Find the volume of this here. So that's the volume of this cone plus half of a sphere, or we call that a hemisphere. Okay, so this volume is going to equal this cone right here. So the volume of a cone is 1/3 the area of the base times the height, right? 1/3 of this base. Now the base of that here is going to be a circle, right? So what we want to do here is put the area of our circle in here. So that's pi r squared. And there's our area of the base times the height plus 1/2 of the volume of our sphere. 1/2 of 4/3 pi r cubed. Okay, I know it looks kind of messy, but and you don't have to do that all in one step. You can do those separately, but that's what we're going to end up doing here. So let's plug in what we know. 1/3 pi. We know the radius of this thing is 5. Height is 9. And then this one over here is 4/3 pi times the radius is still 5 cubed. Okay. So we can, let's do this. Let's find out each piece separately, and then we'll add them together just to kind of give us a little bit more clarity on this whole thing. Okay, so 1/3 times pi times 5 squared times 9. So the volume of just the cone piece itself is 235.6. And then we can figure out the volume of the half of the sphere, or hemisphere. So 0.5 times 4. Here, let's do this. We'll even put it all in the parentheses just like it looks. 4 divided by 3. And then times pi. And then times 5 to the 3rd. Not cubed, but, oops. Let's get rid of that and then go over and close it off that way. I don't think you have to even close that off. It'll still work out. But all right. And so the hemisphere is going to be 261.8. Okay. So then we would simply just want to add those two together. So add that. Take the 261.8 plus 235.6. And we get 497.4. And that's going to be centimeters cubed for the volume of that shape there. Okay, next one. Find the radius of a spherical weather balloon with volume 73.62. So, our formula, volume, oh, come on, here we go. Volume equals 4/3 pi r cubed. Now we know that the volume is 73.62, so we do 73.62 equals 4/3 pi r cubed. All right, so we're going to want to divide by this 4/3 pi, so let's do this. Let's turn our 4/3 pi just to make this a little bit nicer on ourselves, let's do 4 divided by 3 times pi, and that gives us 4.189. So let's do this. 4.189 r cubed, 73.62. That'll make it a little bit nicer for us to divide both sides. So divide both sides by 4.189 instead of dividing by a fraction and pi in there. Okay, so we're going to take 73.62 and divide by this number here. So I'm just going to do divide by second answer, and we get 11 point, let's go with 11.6. 11.6 equals r cubed, right? So we don't want to know what r cubed is. We want to know what the r is. So we have to then cube root both sides, right? So the radius equals cube root on the graphing calculator, and many of the scientific calculators you have to do 3 and then find your little x root. So some of your buttons will look like this. It'll be y with an x. Some of them will look like this with just little boxes in there, something like that. But you got to make sure that it's got something up here above the root that you can enter in, so we can put a 3 in there. On mine, I'm going to do math, and I want this little 5, this little x root, and then it's going to turn in the cube root of, and I'm going to just do the answer here. Oops, I put 11.6, but it's supposed to be 17. 17.6. So second answer gives us 2.599, so let's call that 2.6 meters. So about, radius is about 2.6 meters. Okay. All right, one last one to look at. 6, for a sphere of radius r, the volume of the cap of height h is given by this. So here's a new little volume formula. You're not going to need to know this formula because this is very specific to this one problem here, or one type of problem. So, but we can actually find the volume of just part of a sphere that's not like, you know, cut in half or cut in quarters or whatever, but just like the cap of it, it's called. Okay, so find the volume of these caps here. So we're going to find the volume of this here. So let's see if we can't figure out what they're talking about. Volume equals pi, and then let's see, h is just the height of the cap, so that's going to be times 2 squared over 3. All times 3 times r has got to be our radius, right? So, yep, radius. Now, if you'll notice, they didn't give us this here, but they do give us how tall this is. So this 6 here is also the radius. So 3 times 6 minus r h again, which is this piece right here, which is minus 2. Yep, just like that. So now we can just put that into our calculator and see what we get, right? So we've got pi, oops, that's a second pi. There we go, pi. And use the pi button instead of the 3.14 because the pi button is going to give you a much more accurate answer. Times 2 squared, and that gives us 12.56, divide that by 3, and that's 4.188 is what pi times 2 squared over 3 equals. And then I'm just going to do this. Oops, let's see, times, so it's going to give me this answer, times, and let's do 3 times 6 minus 2, like so, and that should give us that just the volume of just this little cap piece right here is about 67. So volume is about 67 cubic centimeters for that one. Okay. All right. That's all we have for 6C Part 2. If you have any further questions on any of these or any other problems from this section, please feel free to ask. Thanks.